Hello class, in this video I'll be showing you how to sketch the graph of a rational function containing a removable discontinuity. Let's begin. Sketch the graph of p of x is equal to x plus 5 divided by x squared plus 3x minus 10. The first thing I'm going to do is determine the domain of p of x. To do this, I'm going to set the denominator equal to 0 and solve for x. So we have x plus 5 times x minus 2 is equal to 0. So x is equal to negative 5 and x is equal to 2 are the solutions to that quadratic equation. So the domain of p of x is the set of all real numbers x such that x doesn't equal negative 5 and x doesn't equal 2. Now I'm going to rewrite p of x with a completely factored denominator. What you'll see is that the numerator and the denominator share a common factor of x plus 5. So if I divide those common factors out of the rational expression, we are left with 1 divided by x minus 2, provided that x doesn't equal 2 and x doesn't equal negative 5. Since we removed the factor x plus 5 from p of x, the question is what happens now if x is equal to negative 5? Well, if I substitute negative 5 in for x, this will equal 1 divided by negative 5 minus 2, which is negative 1/7. So there is a hole in the graph at negative 5, negative 1/7. So I'm going to go to the grid to the right and place a hole at negative 5, negative 1/7. That hole will be right about there. Now to sketch the graph. So I'm going to start by finding the asymptotes of p of x. The vertical asymptote is going to be the value of x that makes the denominator 0 after dividing out the factors of x plus 5. So in this case, the equation of the vertical asymptote is x is equal to 2. To determine the horizontal asymptote, we need to look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 0 because there is no factor of x in the numerator. The degree of the denominator is equal to 1. In this case, m is greater than n, so y is equal to 0 is the horizontal asymptote. So I'm going to sketch the two asymptotes on the grid now. Now I'm going to find a couple of points on the graph of p of x, starting with the vertical intercept. To find the vertical intercept, evaluate p of x at x is equal to 0. The vertical intercept is negative 1/2. So the graph crosses through the point 0, negative 1/2. To the left of the vertical asymptote, the graph will approach the horizontal asymptote like such. There's a hole at negative 5, negative 1/7. Then it's going to cross through 0, negative 1/2, and then approach the vertical asymptote just like that. Now we're going to pick a point to the right of the vertical asymptote to see where the graph lies. I'm going to pick the coordinate x is equal to 3. So p of 3 is equal to 1 divided by 3 minus 2, which is equal to 1. So the graph crosses through the point 3, 1. I'm going to place a point at 3, 1. So the graph is going to approach the vertical asymptote like such, and then approach the horizontal asymptote just like that. And this is the graph of p of x is equal to x plus 5, all divided by x squared plus 3x minus 10. And we are done.